Hi everyone, we are Group 28. Today we are really excited to present our project. We have developed a custom programming language that we have decided to call OOPSie. So what is OOPSie? OOPSie is a statically typed language that is interpreted. It is inspired by the simplicity of Python and is structured familiarly with those who have developed code in C, C++. Our main goal with OOPSie was to create something that's easy for beginners to pick up, but also powerful enough with more experienced programmers to use effectively. Now, let's talk about how we built it. OOPSie is developed entirely in Python. We
Smit,
used, okay, thank you, Smith. We used a tool called PLY that stands for Python Lexer and Yak. This tool allowed us to define the language grammar and build both the lex and parser for it instead of compiling code into machine language. OOPSie interprets it directly so users can run and test their code quickly through the command line. OOPSie is also designed to run on both Windows and Mac OS. You can write and execute programs using a terminal or command line interface, just like you would with any other language. Uh, Passing on to Smith for its features and grammar. Thank you.
so thank you so much, Jitesh. Now let's look at the grammar of OOPSie. Can you hear me? Yes. So let's look at the grammar of OOPSie. We used a formal context-free grammar, CFG, that defines how valid programs are structured. It includes rules for statements, expressions, control structures, and variable declarations. So, for example, statements are like things like integer x equals to 10 and cout x, which provides an output, or if x equals to 0, then block, which is a conditional block in sense, and loops like while and for the um, for in terms of loops in our language. So, in terms of feature, we support five basic data types, namely integer, float, bool, character, and string, as you can see in our slides that along with data types. And along with that, we support control structure like if-else blocks, while and for loops, which are with a really familiar syntax. And along with that, we also uh, we also include perform operations that we have added, such as standard arithmetic operations like plus, minus, multiplication, and division, then logical operators such as and or not, and as well as the relational operators like less than, greater than, and equal to. In and additionally to that, we have also included a ternary operator, as we can see in the screen. The syntax looks very similar to the very known programming languages. And you'll also find similar output syntax using cout, which prints strings and variable values. Now let's go behind the scenes and talk about how OOPSie compiler works. So Tanmay will walk you through how it actually works. So on to you, Tanmay.
Thanks, Smit. Now let's explore the compiler pipeline that powers OOPSie. OOPSie is built with a clear and structured compilation model. It begins with lexical analysis, where the source code is scanned and then converted into a sequence of meaningful tokens like identifiers, keywords, operators, and constants. This is handled using PLY's Lexer module. When we have defined where we've defined comprehensive token patterns that reflect the language's grammar. Next, these tokens are passed into the parser, which we also built using PLY. The parser applies a context-free grammar to ensure that the syntax is valid and builds an abstract syntax tree. A hierarchical representation of the source code's logical structure. This tree is essential for understanding how nested statements, arithmetic, and control flow constructs are organized. To execute the program, we use a custom interpreter that walks through the AST node by node evaluating expressions and performing actions like printing, looping, and variable assignment. This approach keeps the runtime lightweight while supporting features like Booleans, typed variables, arithmetic, logical operations, and even ternary expressions. To make the entire process more transparent, especially for debugging and educational purposes, we've integrated Graphviz. It generates visual parse trees that give a clear view of how each statement is interpreted step by step, which is particularly useful when analyzing deeply nested or complex expressions. Now let's look at a simple OOPSie program to illustrate further. Smith, if you could just move to the next screen. Yes. So in this example, a while loop executes only once. Since the flag is true at the start, the body of the loop runs, printing 0, incrementing I, and then immediately setting flag to false. The condition is no longer true in the next iteration, so the loop exits exactly as intended. The interpreter executes this correctly, and the generated parse tree confirms the proper structure and evaluation. The sample not only shows off the syntax clarity of OOPSie, but also validates the reliability of our compiler components in handling real control flow logic. Now I'll pass it over to Somesh, who will take you through what's next in the future roadmap of OOPSie. Thank you.
Thanks, Tanmay. Yeah, future scope. While we are proud of OOPSie's current capabilities, we are more excited what about coming next. We are planning to add data structures like in our language like array, list, and dictionaries to enhance data storage. We are also planning to add user-defined functions, which will enable modular programming to define reusable functions. We are planning to introduce error handling, uh, which will which will help to improve debugging, and OOPSie will have file handling support, which will has read and write functions features also. The main focus will be on our object-oriented programming. We are planning to add classes, objects, and inheritance to allow structured and scalable application development. Now I'll pass it on back to Smith to explain a demo for OOPSie.
Thank you so much. Now we'll look at how OOPSie actually works. So this is our this is a sample OOPSie code that you can look into. It is basically it shows a ternary operator and says that if x is greater than the y, then it will print true, else it will print false. So now in order to run the OOPSie code, we first run the runner, and then we put in the relative path of which of the file that we need to run. So in terms of we'll run the ternary.oops. So we'll copy the relative path for that and paste it here, and then simply just click enter. So let's go to the output one by one. So first of all, it prints the source code, that is the code. After that, it gives out all the tokens that the organizer has generated, and after that, it creates a syntax tree or the parse tree of the based on the tokens, and then saves it into a parse tree.png. That if we look into our directory structure, we can correctly look that this file is generated and correctly shows the parse tree for our program. And at the end, it gives the program output, which is true as we earlier discussed. So, so
Let,
it's true as x
let's
is greater than y.
also try to change the value of x to 10. Let's give it a shot.
Okay, thank you, Tanmay, for pointing out that. We'll now run that again. So yeah, it gives output as false since now the value of x is less than y, so it triggers the ternary operator and prints out the false statement. So moving forward, we'll dive deeper into how the tokenizer and the parser and the parse tree are working. So to explain that, I'll pass the stage on to Jeteish. Can you explain that in much more detail? Thank you.
Hi. So can you move to tokenizer.py? Yeah, thank you. As Smith mentioned earlier, we have a very similar syntax and keywords that are very similar to C, C++. As you can see, we have reserved keywords for if, else, while, for, very similar to C. But the only difference here being all of them are caps. Currently, we are supporting primitive data types such as int, float, bool, char, and string. Smith, if you can just open string.op so we can see it in action. Can you just open? Yeah. So if we want to run if we want to use strings in our code, we'll use string keyword as indicated in line 1. We are using string keyword for yeah. It now displays something as a string. If we want to just display a single character, we need to use char keyword for that. If you Smith, if you can just replace string with char, that would be great, and just enter anything about a b or some character. Replace it to single quotes. Yeah. Save it and can you run it once? Yeah. So if we want to if we want to use if we want to display a single character, we can use char. If we want to display a stream of characters, we need to use string. Similarly, if we look at parser.py, Smith, can you open that? Parser.py basically just ensures that the source code that we provided that the .ops file is adherent to the syntax rules that we decided upon. If we look at an example function for it, yeah, if we look at line 49, we have a rule that is this rule ensures that assignment statements such as if we have a statement like int x equals to 3, it is always in the form of id assigns expression being anything, and it ends with semicolon. This script also generates parse tree or ASTs. What we are doing is we have decided we'll use Graphviz. So this also develops a PNG image for that graph tree, helping us visualize it a bit more easier. Smith, can you open main.py now? So main.py, a script acts as a controller for our project. What it does is it links every script that we've discussed so far to one another. So tokenizer feeds into parser, parser feeds into interpreter, interpreter then ultimately gives us an output. Thank you for staying with us. This was OOPSie. Thank you.